ലൈവാണ്. വാല്യൂഷൻ ഞാൻ ഇടയ്ക്ക് അവരോട് ചെയ്തുകൊണ്ടിരിക്കുന്നത് ഒരു ഫാനല്ലേ കംപ്ലൈൻറ്റ് സ്ലോ ആയിട്ട് സാധനങ്ങൾ എത്തിയില്ല. അതൊക്കെ പുതിയ റിക്വയർമെൻറ്റ് എനിക്ക് തോന്നുന്നില്ല.
Sukumaran will engage in the class, and before that, Ritika will be introducing Mr. Sukumaran.
It's a great honor to introduce our esteemed alumnus, Mr. Sukumaran, from the 1993-97 batch. Mr. Sukumaran brings with him a wealth of experience and expertise in the transportation, trucking, railroad, marine, power industry. His skills encompass engine control and management systems, embedded software, control systems, engineer, advanced.
Okay, so actually, I don't want to just read through the I'll just try to go through a bit of my experience, what I was doing, what are the new things which we have been doing in our center, and we goes to, I think he has already introduced what I was doing. So, born and brought up in Calicut, I see government school and father retired. We moved to Bangalore, government college, reading second college in Kerala. EMS MD was there. Facilities was not that good. We started putting together things along with the faculty. But the lab, machines lab, then maybe during my project, our guide efforts are casually chatting on the administration. I'm sure. How many of you are from final year, and is there any appendix? No, 5 years. Okay. So, 7 years, guide waited in over. Honestly, I didn't know what to say. And then some contract engineering substation work and got a case for, and then applied and issue, and got into both. And decided to go for CET on the control system, and then 5 years is easy to BSc right now. GSLE launch paper. So got an opportunity to spend a bit of time on that on an autopilot project, and that's the first time I got introduced to MATLAB. We have MATLAB here, the lab. Good. Continue spending a bit of time will be useful here and to go out. So out of credit I need to then went to Bangalore straight away. Probably I spent about 3 days at it. That's it. And then directly went to Bangalore. Joined a company called Train Software International Limited, and was working on conversation domain in MATLAB, State Pro. Was working for some of the it was a services company, so we were taking projects from. Correct. Yeah, they were the distributors of MATLAB in Asia Pacific at that point of time. Because MATLAB never came to India at that time. I think they entered India in 2000 or something like that. Till that time we were looking at it. So HCL, some other defense organizations, some small projects, and so the GE, several projects here and there. In 2004, I moved to the General Electric. I hope you know about that company. And there is a division called GE Transportation. And in 2018, GE decided to focus mainly on the so GE decided to focus mainly on the aircraft engines and healthcare and power business. So that time they decided that okay, we will come out of transportation business, and there was an 20 years in that same company. So okay, so personal friend, married, wife is working in Bangalore. She is an electronics engineer working in EEE. You are into telecom with the PGS and that's the technical understanding of those. She works in 001 and I work in between on the other stuff. Two kids, daughter is in 11th and youngest son is in 4th, going to the 5th standard. Okay, and that's all about myself. Any questions so far? Any questions? So, on a professional front, what I was doing mainly is initial days when I joined GE, I was working on DC locomotives, cranking systems, and how to start the engines and electrical side. Then, around 2007 time frame, GE decided to enter into the marine stationary business, and that's the time I got introduced into engines. And I have no background on engines, and if you think about an engine, you immediately comes to your mind is a mechanical, not electrical, right? So, no background, studied on the engine, what, how the engine works, and what needs to be controlled on that engine. So, I have worked on medium and speed high power engines, big engines, which is used in the locomotive engine. Everybody knows what is a locomotive? We usually got train engine. So basically the engine goes into that big box which is really called as a locomotive. It has lot of other stuff also. The range of those engines are like the power range is you can see stuff going from 2250 to 6000 HP engines. And what is a car engine? Any student? A diesel car engine, how much do you call it? Even typical diesel engine. It can be wrong, there is no marks for it. So, roughly, no? 1900. 1900, yeah. The area which I have, that's a 2 liter and that is around 64 HP. So you can imagine, compared to a car engine, how big this will be, right? So the engine is huge. We do, when you're saying about engine controls, there is a big importance in the emissions standard. And you guys have heard about something like Bharat stage 1, 2, Bharat stage 6. Right now it is Bharat stage 6. All our cars. In the back side you see, you are seeing Bharat 6, right? That's the emission standard. It says that, okay, this is the hydrocarbon. Gross phosphorus. No, we usually rate it as GHG. We use both, but typically we call it as GHG. So, Tier 4 is the most stringent emission standards at this point of time in the world, and our engines meets that one. And there is some also Tier 4 coming up. So, worked on few things called the fuel saving technologies. Basically, when you operate two locomotives in transit, you would have seen some big long freight trains, good trains which is going with the two engines to the coupled to the right side by side. So we worked on few technologies to how to save fuel if you are operating two locomotives in transit or two locomotives together. Basically, the power levels are less. I mean, the power levels required is less. Can you, two ways you can do. Typically what we do is both the engines will be running at the same power. We come out with some kind of algorithms saying that, okay, I can optimize that and I can increase the power of one engine to an optimum point and reduce the power of the other engine to a lower level so that we can save some fuel. And saving the fuel two things: one is cost of operation, second one is emissions. Spent a period of time around that one. The latest one I've been playing around was hydrogen fuel cells. Okay. We are thinking of putting hydrogen fuel cells into the locomotives and can we run the freight locomotives and the power levels so that it's going to be zero emissions. No emissions, no hydrocarbons, no. But point of time. So there is quite a few research is going on region to make the hydrogen manufacturing or hydrogen production pretty cost effective. So this one probably will come from what we are expecting. The hydrogen fuel cell technologies will be maturing close to 2030, 2035, and hopefully I will be able to see before I retire. Okay. So that's my professional side. Little bit about our company. Like I said, we are the world's leading freight locomotive, goods locomotive. We don't play anything on the passenger locomotives, neither on the electric locomotives. This is purely on the diesel, the world's largest one. We have about so little bit of history of this particular company is you can see the transportation started by Edison. Everybody had hope knows Edison. Okay, good. No name. In 1889, so you can think about probably 150 years old, right? And then there is he had a competitor in US. His name was Westinghouse. He was an inventor who was working on air brakes, and roughly around the same time frame, he also started a company for the back home. And then there was in France, there was another inventor, later, 1912, called Feveli. Feveli is mainly into the locomotive components like the roads and air brakes, pantograph, and all those things. The electric locomotives you would have seen offered those pantographs, so there's some works on that one. So these three companies decided to come together, and you can see the number of engineering experience that is coming into that one entity, probably about 300 years of engineering experience is coming together, the engineers coming together. So it's a Fortune 500 company currently, about 9 billion revenues, 25,000 employees all around the world, operating in 50 plus countries and 23,000 plus locomotives running in the field. We do work on remote monitoring and diagnostics of this locomotive, meaning you can watch these locomotives running in the field live from our data centers. Continuously the data is getting transmitted to these locomotives to the data center, and we can detect if there is any issues on those locomotives upfront, and then call them or send mails to the customers saying that there is something wrong with your locomotive or something going to fail, and things like that. So, the optimizer is a system which is developed in the last 10 years, probably about 100 pages around that one itself, which is if I draw a parallel with the automotive, but it's kind of like a cruise control for the locomotive. It operates by itself. It doesn't, operator is required to start and stop, but the rest of the system will take care of running it automatically. Electric locos mainly around doors and air brakes I told already. So if you look at if you I don't know about the Kochi Metro, but if you look at the Bangalore Metro, you will see other doors being used, doors and those kind of things used there. Marine and stationary, we work on big vessels with these engines, but marine and stationary we don't make a full ship. We usually make only the engine and engine control. Rest of them is done by some different companies. Mining, the big mine, I don't know if you have seen those OHV, machines. The other tires which is probably bigger than us, right? Those kind of places operating in the mines. We give electric drives to that one, and Indian Railways we have given about 1,000 locomotives. That order is still going on. About 600 is already delivered. You will see those if you happen to travel north side. There is a dedicated freight corridor between Delhi and Noida and Haryana. So that's the region where this particular locomotives are running. Bangalore Center, we have about 700 plus engineers of various streams. We have different streams also. This is some of our locomotives. Across the world, I had the opportunity to work on many of these, may not be all of them. So, okay, it doesn't show that. The second one, LBS, the Kazakhstan locomotive, Romo, the Indonesia locomotive at the bottom. I get the engine control development for that one, for both engine control unit and engine management system. Egypt, right line UK. I have rode on this UK locomotive, Indonesia locomotive. I have traveled on that and drove on that one in the plant. Our plant is in EEE, and we continuously go there to the testing as well. Once you develop the control system, make the software, go there, load on the simulators and the locomotive, and you get the opportunity to actually not only sitting in the passenger car, you can sit on the operator's cabin. Right on that road. So that those are few of the locomotives which we have few of them. Okay, there is more like that. So you can see these are big locomotives compared to what we see on our normally here. Our locomotives here usually it is around 3000 HP range. These are like 4500 or 6000 HP. This is our Indian locomotives, two of them, 4500 HP and 6000 HP. One is a 16 cylinder and the other one is a 12 cylinder. I have the opportunity to work on that as well. And this is the India's most powerful diesel locomotive at this point. And it pulls quite a bit of freight. We have 1000 locomotives, about 500 plus is already developed and completely built in India. Region, we have big plants there, and we are completely developing. The engine comes from US, but the entire assembly line is in UP and the Rosa. And this picture with bottom you can see that's the first time in the history of India a freight locomotive reached Bangalore, Northeast, and that was a locomotive. This happened in 2022. Because the terrain is so difficult, normal locomotives cannot reach there, so our locomotive was able to go through that terrain and take the flight. Because think about that one region in India is still not having the rail access. Okay, so this is about Indian locomotives. Some of the marine vessels here, even our engines. So the marine business, the engine control completely led by me, and their team for both engine control management system, and these are few of the vessels which we have. You can see those two bottom, National Geographic, those to the North Pole for the expedition. So you can think about sub-zero temperatures where these engines need to continuously run because it's not just the propulsion, it is the power, the entire ship needs to go from our engines. So what if that engine gets shut down, like you're out of power, right? And nothing works, no features, nothing. So safety is very important. I don't know how many of you have seen in recent news in US or Baltimore. There was one ship, one container ship, lost the power, engine got shut down, blacked out, and it lost before I go there, how do you break it? What are the ship? How do you break? How do you stop? When it is moving in water. Yeah, reverse. So you need to have power. The only thing, other thing that you can do, you can drop the anchor, but that's not the right way to do it. So if your propulsion engine is shut down, you are done. It's just like, may not be that catastrophic, I would say. Like if you're flying, if you're going in a flight and the engine fails, what happens? The ground. It just drops, that's it. Okay, so in this ship, when the curve went off, it lost the control of the ship and it went and hit a historical bridge, and the bridge collapsed. And the bridge, on the bridge, where the YouTube view, you can see the video, there were cars and trucks were moving. Just before, in fact, they restarted that power, engine, but they couldn't be able to sustain and it went back. So this engine space, it's a big failure and it can have huge accidents. The first one is a Tier 4 engine and that's run in Norway, or let's say the Norway region. And that is a special one where you have only one engine on the vessel and it is a ferry, passenger ferry. So you need to take the people from one side to the other side of the river. And so to get that approval of that particular vessel, there is a stringent condition that if there any electronic space on that particular vessel, you should be handling it back. So single engine, so if your ECU fails, you are done, right? You cannot say, you cannot control the vessel. So what we did was we provided a standard ECU, a separate ECU, one more which is running parallel to the current ECU, and if that ECU fails, if main ECU fails, the entire control switches to the second ECU on the flight. And the entire fuel injection switches from one control to the other control. We got it certified, it's currently, because you can think about if you are crossing a river, okay, not on the river, but if your engine is lost, you will just throw it to the river. You can go and see somebody else. Yeah, that's these are some of the vessels I was able to. I had been to one vessel, not in this one. I traveled to Mississippi River. There was some issue was going on one of the engines, so I got the opportunity to get into one of the vessels in Mississippi River. Just very top level. What the one which is running in our, this is similar to what we have here also, the research of this one is. So you can see the components which is going in. We have that blue green one is an engine, then there is an alternator. The alternator is the alternator output is converted into a DC, and then the DC is again converted into an AC, and then AC traction motors are done. Along with that one, you will have so many auxiliaries like compressor for the brakes, the blowers for cooling on the electronics equipment and the motor. Then you have the radiator fans, like our automotive. You have the radiator fans to cool the engine, and air brakes, operator cabs with HMIs and stuff like that. So you can see a complex system, and when it combined with system which is mechanical as well as a electrical system, right? So whatever we can see some of the control systems which is multiple control systems, or we call it as subsystems, that is being upgraded on the locomotive. You will see there will be a management system or a supervisory control, there is an engine control separately, an alternator control, traction motor control. Addition and mistake, these wheels can sit on the rail. You can search in the YouTube, you can see some of physically the wheels will sit on the rail. If you do not get the proper friction, and it can damage the rails as well. And you can go on because these are so heavy that your rails can damage. So we actually inject small quantity of fine sand into the rail so that you get a friction of that. So the control system needs to quickly detect if the wheels are slipping or not, and then inject the sand into the rail so that you get friction back and you can move forward. Dynamic brake. I hope most of you are familiar with the dynamic braking of electrical machines. We use that one here. Moving and back fan controls, compressor, ventilation is already told. We also have some systems like auto engine stop. The engine is not being used. It is idling for a long time, and for conditions of good, we just automatically shut down the engine. And whenever it is required, we will automatically start the engine. DPs, I haven't seen DP systems in the India goods where you have one locomotive at front and another locomotive maybe at the middle and maybe at one of them in the bottom, long trains. Okay, so from the first locomotive you can actually control the other using the radio frequency signals. You give the same commands to so it's wireless control. So we do that one. So it's a very common system because if you are going in a curve or if you are going on a hilly power levels. Because and the front locomotive is already done and the back one is pushing. If the pushing is on, you can actually brake the brake and brake in the middle. So we should be careful about how you apply these things, and this system will take care of such scenarios and things like that. We have heard about college system in railways. That's an anti-collision avoidance or the collision avoidance system, which is developed by Indian Railways. We do have something similar to that one that we have also. Basically, if two trains are coming face to face on the same track, they can detect and then you can automatically brake. So the operator probably LC or watching predictor of the rail, so happens. So those are kind of safety mechanisms that is being currently applied on these locomotives. Indian Railways also have some of those. Alligator is another one. It tracks the movement of the operator. So the operator is not moving or the driver is not moving. It applies safety risks. The idea behind that one is that person, say, PC can not able to do the operations, right? So if the operator is not moving for more than some minutes, usually people will not sit that idle for such a long time without any movement. So we take the moment of the operator, and if the operator is not moving after the break, because we do not know whether he has left off or whether he is having a heart attack and fell or whatever, right? So those kind of safety against. Some of the networks so all these control systems are at different ECUs or different panels. These will be running in real time, and these all need to be communicated with each other, right? For a better coordination of all this. We have networks like Ethernet, ARPANET. ARPANET I don't think you will be familiar with. It's a real-time communication protocol. CL, CAN. We use all of them. The communication between all these different controllers, back control panels, and parallel coordination. Questions? Tell me if I'm going too much. Okay. I can answer the questions if you have some specific questions. Okay. Fine. Or do you have questions at the last? Engines. These are our engines. Okay. Starts with the top or left is a FDL, the oldest one before 2000. It's a three variations, 8-cylinder, 12-cylinder, 16-cylinder engines. Comes the 2000 time, we developed the Geo engines, 16-cylinder. Then there is a inline engine, smaller one, Geo. That's a common rail engine, which is a P616. Then we have numbers like 12-cylinder, Gear 4 engine. That's the latest one in the most top. On the bottom left corner, that's fast fuel engine what we have currently. The next one is an inline Gear 4 engine. The blue one is a new engine, probably new engine in the sense like 2017, right? With that particular engine, that is a very engine report. That's a small slot which we have, which is still 3000 HP and high speed 1800 RPM common rate. And I was leading the full control development for that new, which is running in Switzerland and Shandra applications in the service. And this is something which we have started working on probably last 2-3 years, like the old FDL engine, which is a nucleus fuel injection system. We are converted, these engines are designed for 20 years, without any issues, these should work for 20 years. With minor modification into the power oil and things like that. So what we are now currently doing is that nucleus engine we are putting a common rate and then continue to run for the power. Anyone knows what is CRDI? I've seen that, right? On Volvo buses, the lab you would have seen CRDI, common rate diesel injection. Okay. What is the difference between normal injection and CRDI? What about? And also a tangent. Okay. So common rail injection is basically you pressurize the fuel to a very high pressure levels and then inject the fuel into the cylinders. You will get better combustion, better the new diesel engines. Anyone knows about the normal engine fuel pressure? Typical non-CRDA 7 bar range, 7 to 8 bar range. Common range is like you can see that 2200 bar. If there is a leak and if you are on that path of that jet, you can directly go. Simple, very straightforward. Okay, so that's a question what we are talking about here. So we have safety mechanism on the fuel line like it is at every word. Two tubes will be there. Okay. Now we have seen the engines. Let's see how big these engines are, right? You can see the person standing next to the engine on the first one. It's taller than the engine will be almost like this side, like 6 or 7 feet high. That's a vessel, the marine ship, 2 engines side by side. You can see here also a couple of people standing bottom. So these are really big, but I will not say these are the biggest ones. There are companies which is called Varsila. The engine to be as big as this one, which is used in the container ships, runs with crude oil and probably 100 RPM, 200 RPM kind of range, but huge one. So some of the pictures from inside the operator can see some of the operator displays and the AC feature operating cabs and everything. Those two are the marine control system, HMI, the white boxes you can see inside, you have ECUs. Anything else? Impressive? It's a purely mechanical manufacturing. Okay, what we do inside the engine or the engine control, or what we do within the engine control system is we need to start and stop the engines. So how do we start the locomotive? is we have an alternator, I showed that picture, right? The alternator is connected to the engine. We run the engine as a motor on the battery. Run it at probably around 40-50 RPM, and then the AC will start to. So diesel engines, how is the combustion happens? What is the difference between diesel and petrol engines? Yeah, one is you need a spark plug and then you need to have diesel engines do not require any spark plugs. It's purely based on the combustion and the temperature you are facing. So while we are running the engine or taking the engine at 40-50 RPM to data that pressure inside the cylinders. So we run those big alternator as a motor, and then once the AC starts injecting here and it starts making the torque and the power, then the AC will start rotating the engine. And then once it goes about to 20 RPM or something, we disengage the alternator, we will run the alternator as an alternator, not as a motor, and then start. So it's probably about takes about 30 seconds to start an engine like this. Before that, we need to make sure that your engine is zero, what the temperature, everything is full system is proper, and what will start this. We will control the speed control, how do you control the speed of a input on a discussion. We have in the lab, we have the motor and alternator combinations, right? In our machine set. So what happens when you rotate the motor to run the alternator, and then you put a load on the alternator set. So what happens to the speed? Will the speed drop or the current goes up? The motor current. Yes. Your motor and alternator is physically connected. No electrical connection, right? You are rolling on the alternator. What happens to the motor? Yes. It exists. What if I fix that motor current? I will not allow the motor current to go up. Then what happens? The speed drops, right? So to maintain the speed, we need to increase the current. In this one, current is equivalent to fuel. To increase the speed, current just monitor the speed reference, speed drops, you have a speed error, goes to the PID controller, it gives you the output what is required for how much quantity of fuel needs to increase. That is going to be injected. Okay? No, I mean, it is complex, but this is the fundamental principle what we use. Common rail pressure regulator, same thing, we inject more, I mean, we increase the load on the engine or the alternator, the fueling is required to be higher, we inject more fuel, the rail pressure goes down, another PID loop. The rail pressure goes down, pressure, PID increase the rail pressure. So basically there are some valves which can open or close, which will increase the rail pressure. Emissions, I did talk about how you control the emission is basically what is the timing and the duration. So basically what we do is when do you want to inject into the cylinder? So we call it something like when the pressure is the highest point, right? That's the time when we inject the fuel so that we get the best combustion. So we inject that, we will not inject the highest point, we sometimes inject slightly before the atom so that you inject the fuel, you get it all mixture inside the cylinder, and this mixture will be going keeping the pressure high and you get a better power. So that's what the emission control typically we do. That's the one which we use for controlling the emissions as well, or we control for how we make emissions low. You have old and warm engines, strategies around that one, sensors that we failure conditions, and then what else? We edit the tires. We have GPS in this document is where when the locomotive is coming close to the tunnel, what happens when the locomotive goes inside the tunnel? Because when the locomotive is entering into a tunnel, what happens to the air surrounding them? It goes higher because you have the engine exhaust coming out and you are inside a closed tunnel. There is nowhere that heat can go. So the air inside the tunnel also goes up. That's the air going into the engine. That's the air intake. That also goes up. So what we do is we just make sure that we take the GPS, using the GPS we take the location of the tunnel, and then we increase the pull proactively. So some of the control systems are around those times. You can see this chart. I just put that one to get an idea about like the emissions. You can see these are the NOx, hydrocarbons, and particulate matter. And you can see that CL4, RTUSC engine on the outer edges. We need to make sure that our engines are emitting only this much of soot or carbon monoxide and things like that, but only we will get the upwards. Okay, so the next tools what we use. I hope some of you are maybe familiar with MATLAB, Sukumaran. How many of you have used shape? No? Sukumaran? Okay. Okay, there is one more book called Shape, where you can do the programming as a C programming and we extensively use logic controls and things that you can use the Sukumaran book. How many of you have used real-time version? There's another MATLAB tool which you can use these Sukumaran models which you have developed and you convert it into C code. And that C code you can compile and then put it into the processors. You do not need to write C code and handwritten C codes. We develop the models only, make the models, generate the code, and then directly put it into the processor. Embedded C we use a lot, Linux and Linux operating systems, and then hardware we do simulators, JADW, these days, those are some of the systems which we use for HC. So in our lab, do we have any electronic boards? EEE, microprocessor? Microprocessor, okay. Actually, my BTech project was a speed sensor. What kind of a sensor can we use for the speed? To determine the speed. Okay. How the speed? Right, exactly. What kind of sensors you use to separate car or bike, right? You see the scale you say that okay, 40 miles per hour, 40 kilometers per hour, I went in 60, right? So there are many sensors which we use. One of them speed sensor is a variable related speed sensor that is being used here. My project here in our lab was a sort of a DR sensor we made in our lab with a alternator and a motor. In between we just put one small notch and everything. We made that one also in the lake and fitted that one. On the top of that one we just put one clamp like this one. On that one we put some coils. Those coils we connected to an op-amp circuit so that we will get the pulse. 0 to 5 volt pulse. That 5 volt pulse we gave 80, 85. I don't know whether that is still here or not, but yeah. We gave it that 80, 85 kit and we programmed the microprocessor to take the frequency. And then put it into a display which will tell you what is your motor speed automatically. Okay. We till that point we were using that stroboscope or tachometer. And this is automatically measuring what is your motor and our target of your combination in our lab. The project report also must be somewhere here. If it is not completed by someone, it is still a project. Yeah. So that was my project, and I felt very good when I went and started working on some of these systems. These are some of the projects which we are doing in our lab, right? practical applications on this. How many of you are doing projects in banks or is it software projects or is it something hands-on is there, right? So spend time on microprocessors, spend time on EEE. EEE is they have a kit. EEE comes with a kit. So you can do this MATLAB programming for the ceiling model and they have a direct interface with EEE processor. So you can generate the autocode and directly put that algorithm into your EEE processor. So that one and then it's so something which can try okay if you have kit and things like that in your lab. Will be useful but not practical. So I believe like in detection field like you do something physical with wires, with processes, with programming and digital all those things than theory solving hundred lines of equations and getting something. For me, actually is more of doing something in the lab and things like that. Okay, so that's next generation. So we were doing all these tier 4 emissions and things like that when people started saying, no, still it is emitting some greenhouse emission gases and things like that. So what do we do? So we started working on EVs. So this is the EV. You can see the rating 8 megawatt. The entire locomotive is fitted and gray color is all completely batteries. Fully packed batteries. This program is currently going on and probably by the end of this year we will be releasing this opportunity to our customers. So this program is still under work. Are we attend? So battery electric and then next one I already talked about. Battery is still developing technology and few questions being asked like how long your battery is going to last. And typically when an EV you will hear if you ask the service station after 6 or 7 years you need to change the battery. And that costs you about 3 to 4 lakhs on a car. So your car, EV car is about 8 or 10 lakhs and every 6 years or 7 years you need to again spend another 4 or 5 lakhs to change the battery packs. So and then the availability of the battery, the components of the chemicals, materials that is used for the battery also getting lesser and lesser. So we have started exploring into the hydrogen now. So this is very conceptual stage now. We are planning to do the hydrogen fuel cells into the locomotive and try to run that. So idea is take out the alternator and engine from the locomotive, put the fuel cells and try to run that one with battery. So already there is a lab. Questions, R&D sessions. How many of you have fire patents? I will look for PGs. Patents. So while I was coming through yesterday, so this slide was added yesterday night for the bus, and I searched. If you search CET, Dr. Engineering, they have about 9 patents. If you search NIT, they have about 40 patents. From the institutions, why can't we have patents on this? It does give a different view, I would say, a different perspective for the external companies also when we are trying for campus recruitments and things like that. So I would request if there is an opportunity to find some patents, if kids are doing some projects which is kind of like something in certain areas, look for some patents and see if you can put that on. Okay, it's not. Sorry, I'm giving assignments for the teachers, but think about it. Why I asked that one is in Webtec, there is one engineer. He recently crossed the vesting box, which I mentioned. His number of patents, he just crossed 356 patents. Okay? 3 more people in the world is having more patents than him. And he is a Malayalam. He is a Malayalam. He has studied in CET. Way back 1977 and electrical engineer. If he can do 346 or 346 patents, we all should be able to do history, right? I've been to his house and his wife has cooked something being really rice children. So very nice person. He takes something coming to India and he keeps, I mean, for me, fondly say that whenever he looks at you, right, he'll be thinking like, okay, what can I tell on him? That's the way his mind works, okay? He's a very nice engineer. Probably about 73 years now, and he's still an employee of Webtec and not slowing down plateau. He's still pushing for technology, he's still pushing for so. Proud person for all of us, I would say. Kerala, is pushing the entire world, right, in the patent sector. That one, that's mine. Okay. Granted ones. Original ideas, about, I think about 6 ideas, 6 or 7 new ideas. 5 across the world, 6 US patents and 9 more ideas. Granted. So, if I mean, I studied this college on first class, right? And if I am able to do, I am pretty sure all of you can. If you want to do, you can push. Keep looking for some new things, keep working on something. What do you know? Not sure. Okay. I have it in my LinkedIn, all these. Okay, I'll stop here. Any questions? Okay, I can tell you one more thing. There are few people working in the same company from this college. I don't know which batch. There is a Diana Tom. Yeah, she's working in my team. Yeah, she's working in my John Joseph. He is currently in Australia. He is also in Webtec. Anishwara. We have few presentations from LBS. We go to the please stand down. Anything, I mean, not only about this one, if you want to know anything about the industry or anything about the private industry or such. Okay, thank you for the time and all the best.
വളരെ സെഷനായിരുന്നു കുറേ കാര്യങ്ങൾ അറിയാൻ സാധിക്കും ഇതിനെ കുറേ പുതിയ ഇൻഫോർമേഷൻസ് ഈ ക്ലാസ്സിലൂടെ ലഭിച്ചിട്ടുണ്ട് സോ താങ്ക് യു സോ
So now we come to the end of the session, and actually, Suseel, the class was extremely good, and actually we teachers also get about a lot of information, and we are very happy to know that you have 17 patents, work for such a right company, and great work going on the locomotive sector, and also in the control systems of that. I hope that in future also we need to associate and share ideas to our faculty as well as the students. And on behalf of electrical department and our college, I place on record my sincere gratitude and love for being here, not only for the class, but also for the handing over ceremony representing the 1997 batch. And please convey our gratitude to each and every one of your batch that we will remembering these days, and you are just about that. Thank you.
Okay, I have one more request to all the students. Electrical, mechanical, computer science, all those fields, leave it in the college. Don't take it outside the gate. If you look at me, whenever I was talking about this one, how much of that is electrical, how much of this mechanical, electronics, you need all of them. Okay, so please keep all those feelings like electrical and EEE or SCS. We need to work together with all the engineering. So just keep that in mind. I do know that in the college we have bad feelings and things like that, but outside the gate, we need to work with. Again, there is no other option. We need to work with computer science. There is no other option. So thank you.
Thank you. That was a great message. നമ്മുടെ ചെറിയൊരു ബ്രേക്കാണ്, ഒരു 2 മിനിറ്റ് മാത്രം പെട്ടെന്ന് തിരിച്ചു വരാം. നമ്മുടെ ട്രെയിനിങ് സെഷൻ രണ്ടുപേരും ട്രിവാൻഡ്രത്ത് വന്നിട്ടുണ്ട് ഈ എക്യുപ്മെന്റിന്റെ ട്രെയിനിങ്ങിന് വേണ്ടിയിട്ടാണ്. സോ അവർ സ്റ്റാഫ് നീഡ് ടു സ്റ്റേ ഹിയർ. സ്റ്റുഡൻസും കേൾക്കേണ്ടവർക്ക് ഇരിക്കാം, അതിന്റെ ട്രെയിനിങ് പ്രോഗ്രാമാണ്. അപ്പോൾ 2 മിനിറ്റ് വെള്ളം കുടിച്ചുകൊണ്ട് നമുക്ക് സ്റ്റാർട്ട് ചെയ്യാം.